Okay, so let's do a little bit of a different kind of problem. So here I have all these integers, m, n, d, and r. R's got to be bigger than 0 because that's the remainder, and d's got to be bigger than 0 because that's my divisor. Okay, so what do they say? R is equal to m mod d. So what does mod means? That means r is my remainder. So what this translates to is m equal dq plus r, right? Okay, so here I have r is n mod d. Okay, so what this says is this integer n here is some number of multiples of d. I cannot use q, right? I used q here, so I have to use a different letter, and then plus r is the remainder, right? So probably I should off to the side say t and q are elements of the integers, right? They have to be integers. Okay, so what is it I'm trying to show? That m minus n is divisible by d. All right, let's do it. M minus n, so substituting in dq plus r, subtract dt plus r, distributing. Oh, look at that. What happens to those remainders? Those remainders go away. So what am I trying to show? That it's divisible by d? I can do this. So it's divisible, so this is m minus n, so this is divisible by d. This is explicitly showing I can pull the d on the outside. Okay, so that was a little bit of a different problem. Okay, so here we go. Here is a problem where I'm not giving you a hint of how to break up the numbers, but this is what you want to do. You want to break up the numbers so that the product of any 4 consecutive integers is going to be divisible by 8. So I'm thinking, let's do the n equal 2k and the 2k plus 1, right? N equal 2k plus 1. Okay, so let's start with the n equal 2k case. So 4 consecutive integers, n times n plus 1 times n plus 2, n plus 3, right? 4 consecutive integers. Now let's substitute in 2k. So 2k plus 1, 2k plus 2, 2k plus 3. Okay, so let's see. This here I can break up, right? So this would give me another multiple of 2. So I'd have 2k. I'm just trying to see what I've got here, right? So 2k plus 2. So this would give me a 2, and I'll just use a different letter, right? 2t plus 1, right? Because there would be another, this 3 would break down. I'd have another multiple in here, and then a plus a 1. Okay, so what am I looking for? How many 2's can I pull out? I can pull out this 2. I can factor a 2 out of here, right? So 2 and a 2. And I'd be left with a k, a 2k plus 1. This would turn into a k plus 1, and a 2t plus 1. That's not going to do it for me, is it? So I only have a factor of 4 pulled outside. So what does that mean? Breaking up numbers into evens and odds is not going to work. Oh, bummer. Okay, so then what do you need to do? So then you need to think, how is it that I want to break up the numbers? So there's multiples of 2, so that's with d equal 2, right? Do I want to go d equal 3? If I'm breaking numbers up into 3k, 3k plus 1, 3k plus 2, am I going to have a chance, a prayer at a multiple of 8? Not at all. Okay, so I'm not even going to go there. So what if I go d equal 4? I think that's going to do it. Okay, so I need to get rid of this so I can have some room. But I wanted you to see that sometimes you're going to run into a roadblock and you say, oh, okay, that's not going to work. So evens and odds are the nicest because there's just 2 cases. But if it's not those 2 cases don't work, then you have to just kind of march up with the value of d, the divisor, and find out, okay, what is going to get me? So where I need to go. Let's hope it's not, I have to use d equal 8. Let's hope that d equal 4 works. Okay, so if d equal 4, my first case will be 4k, right? So if I use 4k, and again, make sure you write down this, because this is saying this is my 4 consecutive numbers I'm multiplying together. So 4k 4k plus 1, 4k plus, whoops, lost the 4k plus 2, and then 4k plus 3, right? Okay, so I see I can factor a 2 out of here. So I have this 4, and then factoring a 2 out of here. So just going to go slow, and then I'll have k, 4k plus 1. If I factor a 2 out of here, I get 2k plus 1, 4k plus 3. Okay, so this is divisible by 8 because I've got the 8 right there. Okay, case 1 done. All right, so now I need to go do case 2. So case 2, I don't know why that's not erasing. Okay, so n equal 4k plus 1. Okay, so can equal, so start by writing down what you're doing. And substituting it in, 4k plus 1, 4k plus 1, so that'll be plus 2. You see what I'm doing now, right? So 4k plus 1 plus 2, that'll give me 4k plus 3. And then putting in 4k plus 1, I'll get 4k plus 1 plus 3. That gives me 4k plus 4. Okay, so let's see. I'm going to factor a 4 out of this. And then I'm going to factor a 2 out of this. So what am I left with? 4k plus 1. Oops, I didn't write the 4. Okay, so this one here is this one. So I'm trying to write 4k plus 1 times, and I factored a 2 out of this one. So this is going to give me a 2k plus 1, a 4k plus 3, and a k plus 1 because I factored a 4 out. There it is. So divisible by 8. Okay, so then I have 2 more cases to do. Yay, almost done. So 4k plus 2. So n times n plus 1, n plus 2, n plus 3. Okay, so I get, now I'm using this case, right? So this equals 4k plus 2, 4k plus 3, 4k plus, and I'm adding a 2 and a 2, so that gives me a 4, and then a 4k plus, and this will give me a 5, right? All right, so I just need to show divisible by 8, so I'm just going to leave this, even though it's not helpful, right, to write it like that. I'm going to factor a 2 out of this one, and then I'm going to factor a 4 out of this one. Okay, so then if I factor a 2 out of this one, I get 2k plus 1, 4k plus 3, k plus 1, 4k plus 5. There it is. Divisible by 8. One more case. N equal 4k plus 3. So n plus 1, n plus 2, n plus 3. You're getting it. 4k plus 3. Lots of writing. 4k plus 4, 4k plus 5, 4k plus 6. Okay, so let's get the 4 and the 2 out here. So this one will give me the 4, and this one will give me the 2, right? Okay, 4k plus 3 carries along, k plus 1 after I factor out the 4, 4k plus 5, oops, sorry, and then this one here I factored out the 2, so 2k plus 3. So this shows it's divisible by 8.